Now let's discuss how to make use of the tree diagram that you can find on your textbook. Okay, it's the same actually with the diagram on your textbook. So the lowest level will be natural numbers, digits, odd numbers, even numbers. Okay, they all are the subsets of integers. It means if a number belongs to a digits, it must be belongs to integers also. Okay, and then the integers and non-integers are the subsets of rational numbers. Okay, with another perspective is the radicals and transcendentals numbers have the superset, which is rational numbers. Okay, so all irrational numbers can be a radical or can be a transcendental numbers. That's how you see the diagram hierarchy. So let's just make I will give you an example of how to use it. Let's use 3 as the first example. 3 as a number. Okay, 3 as a number based on the definition, it is a natural number. Yes, it belongs to the natural numbers. It also belongs to the digit. Yes. Odd numbers. Yes, it is also odd numbers and not even numbers. So since it belongs to at least one of these, 3 must be integers. Well, by definition, 3 also integers. And 3 cannot be non-integers since 3 isn't integers. Okay? 3 cannot be radicals, 3 cannot be transcendentals. Look at it, there are different branches from the integers. Okay, so since 3 is an integer, therefore 3 must be rational numbers, subset, in the supersets of the integers. Okay, and since 3 is a rational numbers, now it's divided. When you go up, it can be negative, 0, positive. Well, 3 definitely a positive since it is greater than 0. So there 3 must be real numbers also. Okay, so if any number belongs to a set of number that has the at the below of the real numbers, so that number also must be belong to the real numbers. Okay, and since it belongs to the real numbers, it also belongs to the complex numbers. So you can make a conclusion for every numbers that will be given to you, it must be belongs to the complex numbers, since the complex numbers consist of all the numbers that has been found so far, has been discovered or has been exploited so far. So this is how you use the tree diagram. You can find the complete sets of numbers that number 3 belongs to. So how about the second example, pi? Okay, so I know pi by the definition is a transcendental numbers. Okay, since when I square pi, I won't get an integer. Okay, and pi is a endless decimals. So endless decimal cannot be non-integers, cannot be integers. So since this is the lowest level, so you're safe now. You just use the tree diagram to help you, although I suggest you to memorize the definition, but this tree diagram helps you to just find all of the set numbers pi belongs to. Pi, of course, positive since it is greater than 0, so it must be real numbers, it must be complex numbers. Okay, see, use it from here, goes up, goes up, goes up, and goes up. Then you can be safe to present the complete sets of numbers for pi. Okay, so now let's have the third examples, 3.14. Okay, 3.14, it's not a pi. Please remember that 3.14 is not a pi because it is an approximation value for pi, not exactly a pi. This is a terminating decimals, not endless decimals. It means for terminating decimals, it must be non-integers. But if somehow you just by definition, you know it is a rational number, since you can express it as a ratio of two integers by definition. Okay, here. So since rational numbers is not the lowest level of its branch, you need to follow to the subsets, which subset that 3.14 belongs to, integers or non-integers. Since it is not an integers, definitely it must be belong to non-integers. Now, since this is the lowest level, you're safe to go downward. Now you can continue upward. From these rational numbers, of course, you can know that 3.14 belongs to positives, and then it must be belongs to the real numbers, and it belongs to the complex numbers. That's it. And now, next examples. How about square root of 5? Square root of 5. Well, it cannot be one of these, of course. So it must be not integers. Non-integers? No. Since it is definitely not rational numbers, you cannot express square root of 5 as the ratio of two integers. So actually this is radicals. Since radicals is the lowest level for this branch, okay, you don't have any subsets for the radicals. So it's safe for you to go upward. So it must be irrational numbers, square root of 5. It must be positive, of course, and it must be real numbers, and it must be complex number. Okay. Next examples. How about negative square root of 5? Remember, negative square root of 5 is not an imaginary number. This is still radicals. Okay. This is still the same with square root of 5. It's really a radical irrational numbers, but the difference will be here. Since it is negatives, it must be, yeah, the difference between the before, the square root of 5 is positive, but negative square root of 5 is negative. Yeah, it's obviously. So yeah, this is the complete set of numbers where negative square root of 5 belong to. Okay, and how about this one? This one is another different number, square root of negative 5. Before we have negative of square root of 5. This one is square root of negative 5. So this must be imaginary numbers, since you cannot plot this on real number line. Okay, you cannot find the value on the real plane. What is square root negative 5? So it must be imaginary numbers. So yeah, it's an easy task for you, since this number only belongs to two sets of numbers, imaginary numbers and complex numbers. So that's how you use the tree diagram to help you in case you forget the definition. But of course, again, I encourage you to memorize the definition so you can directly know uh, a particular number belongs to which sets of numbers. Okay. And if I want to do a different approach to this, the hierarchy of set of numbers, we can use this diagram. Although for this diagram, I exclude some of the sets of numbers here. So I only include natural number, integers, rational, real numbers, complex, and let me just explain you, there are some of them that's not being written here. So from the circle, this circle, you can see that all numbers are complex numbers. Okay, but inside of this, there are real numbers, but the blue one is not real numbers. Okay, so real numbers only this part, but outside of the real numbers are the imaginary numbers, but both of them are complex numbers. Okay, so imaginary numbers is this one, so the blue one is the imaginary area. Okay, and then let's go inward. This one is real numbers. Okay, but this one is the rational. It means all rational numbers are real numbers. Okay, and all rational numbers must be complex numbers. But this area, okay, since it is not rational numbers, this area belongs to irrational numbers only. So this is irrational numbers. This one is rational. Combined, they all are real numbers. So if I find irrational numbers, this one is the irrational numbers, negative square root of 11. So this area, particular area, is for the irrational. Now let's go inward. This rational consists of integers and non-integers. So the non-integers is this area, the green one. Okay, the non-integers from this example, yeah, this one. Okay, and so how about the yellow one? The yellow one, since it is integers and this is natural. Now, don't forget that natural numbers our counting numbers begins with 1, 2, 3, 4, 5. Natural numbers doesn't include 0 and negative. So it means all negative numbers and 0 integers will belongs to the yellow one. Okay, the yellow one is the 0 and the negative integers, but this one is the positive integers. For example, okay, that's how you, if you want to use the circle diagram, yeah, you can do that. But of course, I suggest you to do this to identify the numbers with this diagram because it's more complete than the other.